Hello, so let's have a look at a parallel plate capacitor as shown in this picture. You have two parallel plates, that is plate number one, that is plate number two, and that is placed in such a way that they have a parallel plate capacitive structure, and in between it is a dark blue layer that indicates the dielectric placed between them. So accordingly, we get the expression for epsilon 0, epsilon r a over D. So A is the cross-section area of these plates. D is the dielectric thickness or the distance between the two plates. That defines the distance between the two plates. And these two plates are conductive plates. So imagine you place you have a voltage difference between the two plates, that is positive and negative, and because of that you have two electric charges of opposite polarities on the two sides of the capacitive plates. So positive Q is on the top plate and negative Q is on the bottom plate, and because of this action there is a surface charge density on the inside surface of these plates. So that surface charge density is indicated by this symbol, and it can be written as plus minus Q over cross section area, and the symbol and the unit of this would be coulombs, coulombs per meter square. So that's the unit for this particular quantity. And from the Gauss's law, I would recommend you to refer to my course on electromagnetic waves, where I have explained four Maxwell equations, and one of them is a Gauss's law that will help me to calculate the magnitude of the electric field between the plates. So because of the charges, there is a creation of the electric field. I just explained you in the previous model, and the electric force will be exerted from positive charges to the negative charges, and the dielectric will reduce the magnitude of that force. So and therefore the capacitance is increased also, as we can see that if you have a higher dielectric constant, you have a higher capacitance. Okay, so how to calculate the magnitude of that electric field? So it would be calculated as E equal to this surface charge density that we know divided by the epsilon, which is the permittivity of the free space. So the voltage difference between the two plates, which is V, that we have applied across the two plates, now can be calculated as with this equation right here. V can be integrated over the distance of the two plates, that is 0 to D. So there is a distance between the two plates, and we can integrate this electric field. It is in the Z direction because the field lines, you can see that it is in the Z direction, up and down, basically. And you have a component of the electric field and you have a dz, so integrate this value, and which is nothing but E multiplied by D. So voltage is given by E multiplied by D, or electric field is voltage over distance. So remember these formulas. So you have this, so value of E we know with this equation. We plug in that equation right here, which is surface charge density divided by epsilon, and we multiply it with the distance between the two plates, which is D. And with this, we already know the value of surface charge density, which is plus minus Q over A. So we plug in that value, that is charge over A, and it is divided by epsilon and multiplied by the D. So you have this equation right over here. Now we know that capacitance is basically C equal to Q over V, and this is the value of V. So we just plug in this value right in this equation, and therefore we substituting the value of V in the equation of capacitance, we get this value, that is epsilon A over D. Just plug in this value of V into this equation and you will get. So this is how you see we derive the expression for the capacitance. Okay. Relative permittivity, if it is dielectric, is air, so that is epsilon R is equal to 1. Epsilon R is equal to 1. So this equation goes as epsilon naught A over D. so which is same as over shown here. Now I want to give you another look at this picture. So you will often in modern day electronics boards, on the printed circuit boards, so you will find in the hardware this electrical passive. So this is called a surface mount capacitor. So you have these two terminal right over here, and across which it stores an electric field energy. Okay, so that was all about this particular module.